Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
And welcome to Lost in Science for another week, your weekly half hour of science on your radio across Australia. My name is Claire, and this week on the show, I'm bringing you a story about krill, who are krilling it, or just killing it, a little bit anyway. Yes, those tiny little invertebrates from the Southern Ocean. Some new research has found that they're actually doing better with ocean acidification than we thought they would. Which is good news for krill.
Yes, that is good.
Yeah, but, okay, spoiler alert, it's not all good news. Is it ever? No.
Not on our show.
Not on our show. We always make sure there's a,
there's a downer in there somewhere.
Yeah. Stu, what do you have for us today?
Well, there's a Victorian election coming up, and I thought I would have a look at another election, another vote that happened last week, but it's not to do with Victorian politics or Australian politics. It's
I'm
to do
sure
with,
a lot of people would be happy about that.
Well, probably. I'm not allowed to talk about Victorian politics, but it's about science. It's about actually how we measure things on Earth. Here on Earth, all the scientists got together and had a vote on the kilogram.
Really?
Yeah.
Why weren't we allowed to vote?
Oh, well, it was just the people who are allowed to vote scientists from 60 countries voted.
Chris, what do you have for us today?
I have another. I realise I do these ad hoc series of stories. I have another story of physicists sticking their noses in and doing stuff that doesn't sound like terribly important. But
is that
anyway.
Because the things that they can do in physics are either too hard, people can't understand them, or like what's going on there?
They try to reach out to like the common people, and then they get ridiculed for it. Like we had the spaghetti snapping story.
I love the spaghetti snapping story. I've got to say,
water plinking. That was great.
Yeah.
All those kind of things. Yeah.
Maybe physicists should stop calling them reaching out to the common people, and then maybe you might get a little bit more traction with the common people.
Common people are so hard to please.
They want to live like common people.
Yeah.
Anyway, so what is it this time?
This time it's poo, I'm afraid. Yeah.
Oh, great.
So physicists have been sticking their nose into poo. Is that what you're saying?
Yeah, particularly wombat poo.
Good one.
Physicists claim that they have solved the mystery of how wombats do square poo.
I mean, is it square or is it cube? I mean, as a physicist, you should really lock that down.
Well, yeah, they say cubical. It's not a uniform cube. Let's be honest. We're not talking a
rectangular prism,
a perfect, platonic solid here. But it is
an oblate prism.
It is basically cubical, but it's got a square cross section.
So they're taking the poo out of the cubicle and spreading it all over the place for everyone to see.
Yeah.
Well, stay tuned for that. On with the show. So, Chris, when you think of food for the animals in the Antarctic, food that's probably in large numbers, feeding even larger animals, what do you think of?
Plankton.
Yeah, plankton's constant. Like,
what else?
Constant.
Come on, what else?
I don't know. Well, I think krill is a kind of plankton, isn't it?
I don't know.
I don't know how plankton's just stuff that's floating around.
Isn't
so there's all
plankton
sorts of
just
stuff.
stuff that's floating around?
Yeah.
Krill's actually
a specific kind of animal.
Species of invertebrate.
It's the kind of thing that you see that giant whales feed on with their baleen, and you think, how can there be so much of this stuff that the whale's getting so big?
Yes. Krill are pretty special for that reason. They are, like you say, the main diet of baleen whales, like humpbacks.
And blue whales.
And, minke. And, of course, the blue whale, as well as penguins, seals and seabirds. But also, you mentioned that they congregate in really large numbers. There are krill schools that have been seen from space. Yeah.
How big is a krill?
A krill can be, so there's like many different species of krill, but Antarctic krill can, be about an inch or less.
Oh, and they look like kind of like a tiny prawn, do they, or shrimp?
Yeah, throw some krill on the barbie.
So they're tiny crustaceans, basically.
They are.
Right.
Yep, tiny little crustaceans.
Throw some krill on the grill.
Throw some krill on the grill. That's great.
You probably have to make them into burgers, though.
Yeah.
They're that small.
Anyway, something else you probably didn't know about krill while we're talking about fun facts about krill. Some of them can live up to 10 years.
It's a long time
Isn't
for
that
a tiny
long
little
time?
creature.
For a tiny little creature that, swarms in large numbers and gets eaten en masse, I think that's quite impressive.
You probably get a special prize for living that long as a krill.
A letter from the krill queen.
Yeah.
Anyway, but so obviously these little pink shrimp, they are some of the most ecologically important animals in the world. But like everything else, they face challenges, and not just from the whales that are eating them. One potentially huge challenge is that of ocean acidification, the process where carbon dioxide in the atmosphere, we've got a lot of carbon dioxide in our atmosphere because we keep on burning all the fossil fuels, increasing the amount of carbon dioxide, and then that dissolves into the ocean water. When it dissolves, it's no longer carbon dioxide. It instead forms carbonic acid. And of course, when you add acid to water, you make your water slightly more acidic, or you lower the pH. And it also reduces the amount of free carbonate in the water. So carbonate is important to have in the water because that's where invertebrates, that's the sort of mineral that they get to create their shells.
Yeah,
exactly, yeah. So animals like oysters, sea urchin, and then crustaceans like krill all need these sorts of carbonates. So if you have more acidic oceans, you have, not only are you increasing the acid, and there's a whole lot of biological issues there, but you're also decreasing the amount of carbonate, which when you think about it and how important the krill are for the whole ecosystem in Antarctica, if we've got a rapidly acidifying ocean, then that's going to be quite a potential issue. However, new research published in Nature Journal Communications shows that krill are actually a bit more resistant than we think, a little bit more resilient. So the study looked at adult krill and how they survive, how they grow, and how they mature in worsening acidification in the oceans. The research came out of the Institute of Marine and Antarctic Studies, and they took a whole lot of krill into the lab, and they pretty much presented the krill with different levels of acidification, so ocean water with different levels of acidification. They then had the krill in tanks for 46 weeks. So one tank was acid levels equivalent to today. One was what we would expect in 100 years, and some was even more extreme than that. And then they measured all sorts of things for the krill, including survival, the size of the krill, what their fat stores were like, were they getting, were they losing a bit of krill body condition, the reproduction, metabolism, and all that sort of stuff. And what they found was that the krill were getting along just fine.
Oh,
yeah,
that's good news.
They just got on with being krill. So the adult krill were able to maintain an acid-base balance of their body fluids as the seawater became acidic. And they did this via this little active ion pump in their gills, which pumps bicarbonate and can maintain their acid base levels. So they actually have the machinery in their gills to help them deal with this ocean acidification.
Okay, that's pretty cool.
So they're basically buffering the pH on their own.
They are.
Yeah.
They're buffering the pH on their own. Yeah.
That's amazing.
Yeah.
Sounds like they prepared, like they knew something was up,
Or maybe they're just, there's some relatives that live in deserts in Australia which come back to life after being completely dehydrated. I'd say the krill.
There were krill in the desert.
There were tiny little brine shrimp in the desert that are related.
Like sea monkeys.
Like sea monkeys.
Yeah.
So I'm just saying that they obviously are of a kind of creature that can exist in different harsh environments. So they must have all sorts of adaptations that they can swing into action when they need them.
Yeah, and I mean, it's really great news considering krill is such a key link in the food chain, and especially because ocean acidification is expected to occur more rapidly at the high altitudes. At the high latitudes. So
The mountain krill.
The Hall of the Mountain Krill?
Yeah.
Is that?
the high latitudes of the Southern Ocean
Okay, yeah.
and the Arctic Circle. But, of course, before we rejoice that the krill will go on in the face of ocean acidification, the researchers do note that this study and the finding is on adult stage of the krill's life cycle, not the other larval stages. And turns out that larval stages are susceptible and vulnerable to the effects of ocean acidification. So, yeah.
So the adults can cope, but the juveniles
Yeah.
can't.
They need to
Yeah.
go through that juvenile phase before they become adults, as my understanding.
Indeed. However, in the paper, it did talk about how the juvenile stages, they would go deeper underwater than the adult stages.
So it's less acidic
And ocean acidification tends to happen
at the surface.
So maybe there's some buffering there. I don't know. And, I guess ocean acidification isn't the only thing happening in the Southern Ocean. It's warming, the surrounding ice is melting. There's a whole lot of other things that are probably happening to the krill. But in the meantime, I think we can agree that these resilient, underappreciated little swimmers are simply krilliant.
Across Australia on the Community Radio Network, you are listening to Lost in Science.
So the Victorian state election is coming up, and enrolled voters will get to choose which state government will serve for the next term. And early next year, the whole country will do the same for the federal government and figure
Sometime
out,
next year, isn't it?
Well,
Yeah.
it's got to be. Yeah, it's got to be
Before
coming
May.
up.
Yeah.
But last week, a different kind of election took place where scientists from around the world got to vote on something else, something that hasn't changed since the 18th century.
Wow.
Was
That's
this
a long term in government.
Was this a proper vote, though? Like, did they have, like we go to the state election and you have, like, a list of candidates and you choose which one. Is this going to be like there was a whole lot of options, they all chose one?
Let's just say
one option.
In electoral terms, it was more of a referendum.
Okay.
Yeah.
Okay.
So really they were choosing, do we keep things the same or do we change it?
Right, okay.
What were they voting on?
They were voting on the kilogram.
Everyone knows that. Come on.
And we covered this story last year, I'm sure, when they were starting to talk about changing the kilogram. This is not something they take lightly. Now, people might think, well, a kilogram is a kilogram. It's 1,000 grams. How can they vote on what a kilogram is?
Yeah.
Yeah. Obviously, they did not vote on how much a kilogram weighs.
Yeah, no way.
No way.
All right.
Yes
Okay.
way.
Yes,
All
way.
right. That joke was not good enough to
Okay.
hear it 3 times.
All right.
They
I've got more.
They were voting on how the kilogram is defined and against what standards specifically the kilogram is measured so that everyone in the world is working on the same basis. So, a kilogram is the international standard unit for weight as defined by the Standard International, which is French. My French is terrible.
Système International.
Oh, Système International, that's true, yes. They abbreviated to SI. So, yeah, the SI unit. It was set out in 1895 based on the gram being 1 cubic centimetre of water at the melting point of ice, which is what they defined it in 1895. They've since actually changed that because they decided that water wasn't at its densest when it was at melting point. It was actually at 4 degrees Celsius. So that changed later on. This stuff is constantly being debated.
Fridge water.
Yeah. Basically, water that drips out the bottom of the fridge.
That's why they chose it, because it was convenient, easy to come by. A lot of fridge water.
Except in 1895, probably
Probably
not, because
wasn't.
who had a fridge? So 1,000 grams makes a kilogram, which is equivalent then to the weight of a litre of water at its maximum density, which is around 4 degrees Celsius. So it's difficult to constantly maintain water at the temperature of its maximum density and also stop it evaporating and avoiding inconsistencies with containers in which it was kept. So they actually needed a standard. They needed something that weighed a kilogram, and everyone agreed that it weighed a kilogram and they could measure everything against this standard. So this gave birth to Le Grand Quai, which is the international prototype kilogram, which is a solid cylinder of platinum iridium alloy, which is kept under very closely controlled conditions in France.
Wow.
And I'm not sure why the French get to keep this, but it's obviously been there since 1895. It lasted through 2 world wars and who knows how many World Cups, I don't know. But, it's been sitting there, and it's in this, glass vacuum bell jar thing, and they take it out every once in a while. No human
Can you
hand is
see
allowed
it?
to touch it. Well, I think you can go and sort of look into the room that it's in, but you can't actually get anywhere near it. And no one's allowed to touch it. No human hand can touch the Le
So
Grand
robots?
Quai. They use tweezers and stuff, and gloves and all the rest of it. But the thing is, if it gains weight or loses weight, it changes the standard of the kilogram all around the world. So everyone's standards will be off. Everyone's calibration will be off. So the international prototype kilogram is the kilogram. It's the kilogram against which all other measures of mass are ultimately measured. So periodically, replicas or equivalents people have all around the world are compared to the original to ensure everyone's kilogram is the same. Although they did find at one point that they brought all of the copies of it back to Le Grand Quai and found that they all weighed different amounts.
Oh.
So either the prototype kilogram had lost weight, or all of the other ones had gained weight, and they don't really know.
did them wrong in the first
Or
place.
they did them wrong in the first place, and So this is quite a big problem, especially when it's probably not when you're buying a kilo of potatoes or anything like that, but when you're doing very delicate scientific experiments and all sorts of things like that. Even payloads and things for sending things into space, all sorts of things. It has a huge impact whether you're accurate or not. So it is important that we have something to compare it to. So it is great to have a central object by which we can measure all things. But the whole idea of the System International and the metric system itself is that our measurements should be based on nature. So in other words, the measures of the universe should be based on how the universe works. But obviously when they started doing this, they made a whole bunch of mistakes when they were setting this up. The meter itself, which is the measure of distance, was supposed to be a certain proportion of the circumference of the globe.
It was a 10 millionth of the distance between the equator and the North Pole it was meant to be.
Yeah, which they calculated wrong. So we're just using the meter that they calculated, even though it's not actually what they thought it was in the first place. But look, it's fine. So the scientist selections, what were they voting on? They were voting on changing the basic standard from using Le Grand Quai as the standard by which everything is measured against to measurements based on universal constants that could effectively be calibrated anywhere. Well, at least anywhere there is a kibble balance. So a kibble balance is not a thing for weighing out kibble. It was actually invented by a scientist called Kibble, who was a metrologist. Not a meteorologist, a metrologist, who is someone who studies measurement. And he came up with a balance that uses Planck's constant to measure the mass of things. So what's Planck's constant again, Chris?
Now, Planck's constant it appears in quantum physics. It relates the energy of a wave to its frequency.
Right. It relies on quantum physics, but basically the constant is constant, and it doesn't matter where in the world you're measuring it. If you have the right equipment, you can figure out how to calibrate that to the mass of an object, and then you can weigh it accurately wherever you are. And this is basically what they were voting on. So Kibble himself died in 2016, but the Kibble balance will be the new standard of measuring the mass of things. We don't have to travel all the way to Paris. Well, one less excuse to travel to Paris to compare our masses to the original prototype kilogram. But the Kibble balances will be used. They can measure small things, they can measure large things, and it will all be based on a universal constant, so it won't matter where you're doing it as long as your Kibble balance is calibrated correctly. Which is, that raises another question. How do they calibrate them correctly? We'll have to find out as that sort of comes into play. There are Kibble balances already in existence, so presumably they will build more as people demand them. But look, this change is not going to happen until May 20th next year, which has been declared World Metrologist Day by the metrologists, presumably, to mark the occasion and give people a reason to learn what a metrologist is. They also voted on changes to the definition of other SI units. They also were voting on changes to the ampere, the Kelvin, and the mole. But we don't really have time to talk about them today. We'll leave that for another. I actually came up with a name for this segment. Size doesn't matter because, if we're not worried about the actual object anymore, we can just focus on something completely different.
So, wombats are pretty amazing, aren't they?
Oh, they really are.
What are some of your favourite things about wombats, Claire?
One of my favourite things about wombats is how they have that extreme pelvis. So when a fox tries to get in their burrow and they're, facing away, the fox gets in the top and then they just crush them with their
dermal shield, I believe it's called.
Dermal shield.
Yeah.
They just crush them.
Their bony bum plates.
Bony or behind.
Yeah.
Yeah.
That is pretty amazing, isn't it?
Kill a wombat booty.
Exactly.
Yeah.
It's a great name for a band.
Yeah.
Yeah.
That is one of my favourite facts about the wombat too. I will admit that. The ability to crush their enemies with their bums. Yeah. That is pretty cool. One of the things they're most famous for, though, is what we're talking about today, which is that they have cubical poo.
Yes, that is also great.
That is pretty good.
Look, can I just jump in and say I like wombat heads as well, so it's not just all about the back end of the wombat. Their faces are pretty cool too.
Their faces are pretty cool as well.
No, okay, yeah, so we're talking about wombat poo. We're not shy from talking about poo here at Lost in Science.
No, especially not you, Chris.
Yeah, all right, well, where was I? Oh, yeah, okay. So anyway, there has been development in the world of wombat poo in that some physicists, because physicists think they can do everything, have, from the Georgia Institute of Technology in the United States, they believe they've figured out how wombats do square poos.
It's pretty incredible that it takes a physicist from the States to figure out this.
It is, isn't it?
Very Australian problem.
I want to point out something
Not
there.
a problem, but a
the physicists
mystery.
have figured out how the wombats do square poo. Not why. That wasn't the puzzle here. They figured out how.
Hey, it's up to a biologist to figure out how.
That's right.
Or to figure out why,
That's
rather.
right.
Yeah.
Well, there was an existing theory for why, and that is because, basically, poo is stinky, as we know. And apparently, wombats, they pile their poo up to mark their territory. They pile it outside their burrows on, rocks and logs. You would have seen wombat poo around if you've been in the wombat zone.
You don't want it to roll.
Yeah, and you don't want to roll away, no.
Yeah.
So that's why they do square poo. How they do it, turns out, was not the obvious reason.
What was the obvious reason?
That they have square bum holes, basically. Square anuses, if you want to.
Right.
That's where your mind goes. Did your mind not go there?
Oh, I guess.
But not only is it square, but it's it's 3 dimensions.
Oh yeah, but
it's square in 3 dimensions. So
it's pinched off.
I know, but they would have to have a square bum hole, and I guess not just pinched off, but sort of like it seems like it goes in segments.
Like one of those
Yeah.
compressors that crushes cars. It would have to sort of be crushed from the side and then crushed from the front and then crushed from the top.
This research is mostly
That's the most obvious answer.
Yeah, that's the obvious answer.
It's got a small poop compressor.
This research is mostly about the cross-sectional side of things. I think we can probably answer the lengthwise bit, because they actually do take a very long time to digest their food. It takes about 14 days for the food to move through the wombat's digestive system, and so it does get very hard and compacted by the end, and I think it probably just snaps off as opposed to being pinched off like
other
animals such as ourselves. Anyway, but they have figured out the square cross-section thing, and it wasn't square anuses. So in this study, lead author, this was actually released at the meeting of the American Physical Society Division of Fluid Dynamics in Atlanta, Georgia. So Patricia Yang and her colleagues from Georgia Institute of Tech, they worked with wildlife ecologist Scott Carver from the University of Tasmania to collect intestines from wombats that have been hit by cars.
Okay.
So, anyway, what they did was they examined the intestines to see what's going on. They found that the magic, if you want to call it that, happens in the final 8% of the intestine. That's where the
shape is formed.
The shaping is done. Yeah. So they experimented on. They inflated the intestines with a balloon. They used like kind of balloon that you would use for balloon animals.
Okay.
Like the long thin ones.
Yeah.
They stick that down the intestinal tube and inflate it to see what happens when there's something inside the intestine.
Did the balloon go square?
Well, it did. They found that there were like alternating bands of stiff and soft bits around. So the looking around the circumference of the intestine, it's not uniform kind of stretchiness. There's like stretchy bits and stiff bits alternating. So in the bits where it's kind of stiff, that's going to be the wall, the edge of the square.
Yeah.
And where it's really stretchy, that kind of pinches out, and that's the corner of the square.
Oh.
See that? They found, the local strain, they said, varied from 20% at the cube's corners to 75% at its edges. So there's much stronger kind of force holding it in on the edges of the square. On the corners, it's allowed to stretch out.
So it's more flexible in the corners.
Yeah.
Okay.
Now, this is what they're saying, though. Apparently, this is kind of, they're stretching a bit here, because they tried to identify these soft and stiff parts, and they found 3 stretchy regions and 2 stiff ones, and they reckon there has to be 4 of each to make it the proper square shape. But they said that their balloon technique could not stretch the intestine enough to really get the limits of it. They needed something, harder and compacted like poo. And so that's the next stage of the experiment, presumably, is to put real wombat poo in a intestine. I don't know how they're going to do that. But anyway, so that's what they have done. Now, as is the case with a lot of these things, you have to speculate about possible practical applications. They said that this could be a new way of making square objects. Normally we will mold things, but now you could just like squeeze them through a tube and
sort of like 3D printing of cubical objects.
Maybe
dice. We could make whole new way of making dice.
Yeah, I don't know that we really need to come up with an industrial application. I think it's just cool enough on its own.
Yeah.
So yeah, good on them.
Well, that answers my question. Who amongst the scientists the most scatological? Turns out it's the physicists.
It is, and it was a pleasure to produce the turd of today's stories.
And that's all we have time for on another episode of Lost in Science, where today we've talked about krill, kilograms, and wombat poo. Lost in Science is recorded in the studios of 3CR and broadcast across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. Please get in touch with us. We are at lostinsci@gmail.com, Lost in Science 1 on Twitter, or find us Lost in Science on 3CR on Facebook. Or just tune in again next week when Stu, Chris and Claire get lost in science.
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.